Normally I can never show what I study because there's nothing really to show. I mean, we're looking at molecules that are at really trace levels. The red head group here makes it like water. The gray-green here makes it repel water. And this gives a very unique property, so it will be at the surface or interface, and that is used when the film-fighting foams are used, because these molecules then basically form a barrier and no more molecules of the fuel can escape and the fire is extinguished. The counter side is that at almost every place where they have been used in training or in real life applications, we have contaminated drinking water now. And that's how people like you or I have it in our blood. So it's not only used in aqueous film-forming foams, but also in other applications like stain-repellant, clothing, textiles. The problem with these is once you produce them, they don't go away. We call them forever chemicals, because once they're made, they really can't go anywhere. I mean, they can't be destroyed, so they end up leaching into drinking water, surface water, soil, sediment, move through the environment, end up in animals, the food chain, and then we can also eat them through fish that we eat. You could get them in the milk you drink. There was just a case in Maine where a farmer had to shut down his dairy production because he happened to apply biosolids from a local wastewater treatment plant, and for whatever reason there was a lot of P4 and PFAS in them, and it ended up in the milk that he produced from his cows, and so now he can't sell his milk anymore. Now that was an extreme case, but as we learn more about these molecules and we look in many more places, we find them, and more places have to be regulated, shut down, cleaned up, whatever. They don't go away because as far as we know, there is no real process to remove them. The only thing that really removes them is once they reach sediment or soil and get slowly buried over time. But that's a very slow and inefficient process for these particular chemicals. The only way to address it really is to stop production of chemicals that don't go away. Particularly if the chemicals like the ones we're talking about end up bioaccumulating, so they go in the food chain and they enrich, and then the problem comes back to us and any other top predators like raptors, seals, polar bears. Polar bears have extremely high levels, so have seals, and of course humans. The family of PFASs, we call it a family because they all have a carbon backbone, they have fluorines, and then they have some different functional groups attached. But so there's 4,700 or so. The exact number is not known. It's a mixture of what is produced by industry and then breakdown products in the environment. Parts of the molecule can react, and eventually they will break down and produce then what we call, again, the forever chemicals. So they break down to the smaller units that don't break down anymore. So they are very abundant in the homes. So it's the exposure, the indoor exposure that we're worried about comes through inhalation, dust, and then of course the contact with food items. So that could be from the pizza box that has this wonderful grease-proof coating. It could be from the microwavable popcorn. But there were lots of uses found for PFASs that mean that we're in regular contact with them, including some bizarre uses like in cosmetics, in dental floss, and some dental flosses. There are all kinds of applications that are really non-essential. And hopefully what we aim to come towards in society is that we limit all the non-essential uses, because it's just too dangerous in the long term. Avoid stain treatments at home of your carpets, your textiles, or anything else. And if you want to use it, then make sure you get a formulation that is without any fluorine, any fluorinated chemicals. In cosmetics, they're sometimes listed, so then you would go with any of the biological brands because they should all be PFAS free. Make sure you know what's in drinking water. All the major suppliers had to be tested under EPA rules a few years ago, and those results are public knowledge. So you want to make sure that your drinking water is clean. That's probably the biggest exposure. If you go to the URI STEEP website, then you can find some more tips and sheets of what you can do at uri.edu/STEEP. There you go.